All right, looking at 38 here, we need to come up with formulas for a of x and b of x valid on 4 to 5. So let's get started here. Just like we did on the last one, guys, I'm going to evaluate a at the first value of that interval, which is 4. So a of 4, everybody, would be an integral starting at 0 and ending at 4. Well, what I see here is that this region and this region just wipe each other out. That would just be 0, and then we would just add the 1 there at the end of that. A of 4 would be 1. And I think I found that already right here on problem 37, so that's maybe not surprising. I'm tempted now to jump to a of 5. The problem with that is, whatever value I get right here, I'm not going to know what kind of function it is just by looking at two ordered pairs. So I better stop in the middle somewhere and do an a of, let's say, 4.5. So a of 4.5 starts at 0 and ends right over here. It's the same integral we just came up with here for a of 4, but we just have to add that little region right there, which is 1/2 times a base of 1/2 times a height of 1. So right there, the area, a half times a half times a 1, is 1/4. This would be 1 1/4, or 1.25. And then for a of 5, we go a little bit further. But now what I notice is that this region and this region wipe each other out. So the value of a of 5 would be the same as the value of a of 4, which is 1. Now in number 37, we looked at these values right here and said, ooh, pretty clearly that's a linear pattern because they're increasing by the same amount, 1, each time. Here, if you look at these three y values, this is pretty clearly not a linear function. Why? Because linear functions don't grow plus 0.25 and then all of a sudden start to decrease. Now, what kind of function does that? What kind of function goes up and then goes down by the same amount? Now, you might have a guess right there. The other thing I want you to notice, though, is this. Let me get rid of a lot of my doodling right over here, guys. The function we're talking about here, f of t, on this interval from 4 to 5 is linear. The real question is, what kind of function has a linear derivative? And the answer to that, guys, is that it has to be quadratic. Now, writing quadratic functions is not something that you guys are very good at, just because you haven't had much practice at it. Not that you're not smart enough to figure it out, but if you look at these as ordered pairs, it would kind of look like this one right here might be your vertex. So let me just mess around with this and see if I can get this to work out. If my vertex were 4.5 and 1.25, my function would probably be something like this. Y is equal to, now I'm not sure I know what my a value is just yet, but then it would be x minus the x coordinate of your vertex, 4.5 squared, and then plus the y value of your vertex, which is 1.25. Now, does that formula work? Probably not. I think I need to figure out what a is. So to do that, let me go ahead and evaluate right here. So again, this is what I think I've got going on for a of x, but I'm not sure I know what a is now. Let's try a of 4 and make sure we end up with a 1. Now again, I don't know what a is, but 4 minus 4.5 squared plus 1.25. 4 minus 4.5 is negative 0.5. Negative 0.5 squared is a positive 0.25. And a positive 0.25, yeah, plus, oh, okay, hang on a second though, guys. Take a look at that. My highest y value is right there. This is probably actually a negative a value right here because it looks like this parabola is opening downward. So that would actually, let's see, if a were just 1, this would have been a negative 0.25 plus 1.25. That gets me the 1 that I wanted right there. So maybe I got really lucky, which doesn't surprise me because I don't think they wanted to make this super hard. And they put a negative right there. That got us 1. Let me try a of 5. that would be the opposite of, that would be a 5 minus 4.5 squared plus 1 1/4. Does that equal 1? That's a half, squared is a quarter, negative a quarter, plus 1 1/4 is 1. So I think we've got it, guys. I think a of x would equal the opposite, or negative 1, times x minus 4.5 squared plus 1.25. As I said, you guys have not gotten a whole lot of practice over the years writing quadratic functions based on a pattern right here, but they made this one work out relatively easily. I do say relatively, guys. It's not a simple problem at all. Okay, half done. Hopefully b isn't going to be that much harder. Let's do b of 4, everybody. So b is the same integral, but it starts here at 2. So the integral from 2 to 4, that region has an area of 2. Then b of 5, we're adding this 1/4 to that, so that's 2.25. I'm sorry, that was not b of 5. That was b of 4.5. Gotcha. And then lastly, b of 5, now we're going all the way to here. Those areas wipe each other out. We're right back to 2 again. And so, let's see if I can slide this up here, guys. Come on. This doesn't feel like cooperating today. Nope, it really doesn't want to move on me right here. Okay, can I do that? Oh, maybe because I didn't write anything on the bottom. That should work now. Okay, so now that we're looking at these values right over here, let's start working on what we think b could be. b of x looks like, let's take a look, guys. I look at this and I see another downward opening parabola. So I'm guessing here this is another negative 1 times, it would be x minus the x-coordinate of your vertex, 4.5 squared, plus the y-coordinate of your vertex, 2.25. Let's see if that works, everybody. When we put in a 4, do we get a 2? 4 minus 4.5 is negative 0.5. Negative 0.5 squared is positive 0.25, but that negative turns it to a negative 0.25 plus 2.25 is 2. That works. The other two are going to work out as well. I'm going to ask you guys to trust me on that, although if this were a test question, I think it would be a good idea to test that. And that is what we've come up with for b of x on problem number 38. So that is definitely a tough problem, everybody, but hopefully you feel like you learned something from that.